We know that everyday living and exercising can be physically much harder when it's really hot out, and this can put us at greater risk for heat illnesses. But our brain is usually very finely tuned to how our bodies are doing and how hot we are feeling. But what if there's a mismatch between how we are doing and how we are feeling? In today's episode, we'll see that not only do older individuals have a harder time controlling their body temperature when it's hot, they may also not be able to sense as well how hot they are getting. Compared to exercising in a comfortable room temperature of about 22 degrees Celsius, our bodies face greater stress when we're doing that same exercise in a hot and humid environment of 30 degrees Celsius or higher. This is not uncommon in some areas the entire year round, but also in many areas of the world during summer. In general, we see a higher body temperature, a higher heart rate, and also a greater sense of effort and discomfort. Usually, our brain uses that greater discomfort to slow ourselves down, make us take breaks, or find shade. Our ability to control our body temperature gets worse as we get older, usually starting sometime after 40 years of age. We are not able to get rid of extra heat from our bodies as well, especially because our sweating response isn't working as well. We know that fitness helps slow down this loss of body temperature control, so we can add that to the long list of why regular physical activity is good for us throughout our lives. But one thing that we don't really know much about is whether aging changes our ability to sense how hot we are or how hot we are getting. So in a 2018 study, Kirsty Waldock tested this by assigning 70-year-old participants to one of 3 different temperature conditions, 15, 25, or 35 degrees Celsius, all at 50% relative humidity. Each group rode a bicycle for 30 minutes in that temperature for 3 different times at either easy, light, or moderate levels of effort. These efforts were similar to what might be experienced just living a normal day, with moderate about equal to that from a steady walk. We have here 2 similar graphs showing what happened with the moderate exercise. On the bottom scale are the 3 temperatures. On the left graph, we see that both temperature and heart rate were higher with each rise in air temperature, which is exactly what we would expect because more heat is being produced because we're exercising harder. But what was really interesting was pairing that observation with the right graph. As we see, the sense of discomfort went up when temperature went up from 15 to 25 degrees Celsius. However, it stayed the same and didn't increase anymore when temperature went up to 35 degrees Celsius. Why is this important? Well, it suggests that older individuals may not be able to accurately sense how hot they are actually getting, so they might not be able to take appropriate care and therefore become at higher risk for heat illness when it is hot. Given rising temperatures with global warming and also more people living for longer, this might require much more work in public policy planning and education. I hope that you've enjoyed this look into the fascinating world of environmental physiology. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab at Brock University in Canada. Check out our other short environmental physiology videos or our longer, more detailed environmental ergonomics symposium series. Thanks for watching. See you next time.